Hi guys, in today's video, I'm going to be continuing with the AP Calculus BC syllabus. I'm going to be discussing the ratio test. This is one more of the convergence or divergence tests which we need to know for the AP Calculus exam. So let's start. So it says that let n equals 1, infinity an be a series of non-zero terms. Then we have three conditions in this ratio test. Firstly, if n equals 1, infinity an. So this would converge. So it converges if the limit n tends to infinity, an plus 1 divided by an is less than 1. Next, n equals 1, infinity an diverges if the limit n tends to infinity, the absolute value of an plus 1 divided by an is greater than or equal to 1. Finally, our third condition says that if the limit n tends to infinity, an plus 1 divided by an is equal to 1, then the test is inconclusive. So the test is inconclusive if the limit n tends to infinity of the absolute value of the ratio is equal to 1. So this is all you have to know for the ratio test. Let's look at a few examples now. So we have to determine whether this converges or diverges. So we have n equals 1, infinity 2 to the power of n over n factorial. So this part is our an. So what we need to do is we need to find what an plus 1 is because of our formula, as we have to find what limit n tends to infinity an plus 1 divided by an. So an plus 1 would be equal to 2 to the power of n plus 1 divided by n plus 1 factorial. So now let's find the value. So this would be limit n tends to infinity an plus 1, which is 2n plus 1, divided by n plus 1 factorial, divided by an, which is 2 to the power of n, divided by n factorial. Now we can move the fourth term and multiply it by the first, and then the second and the third. So limit n tends to infinity 2 to the power of n plus 1 into n factorial, divided by 2 to the power of n into n plus 1 factorial. Now what we can do is limit n tends to infinity. We can simplify this. This can be written as 2 to the power of n into 2 to the power of 1 into n factorial divided by 2 to the power of n into n plus 1 into n factorial. So these two get cancelled off. These two get cancelled out. So what we're left with is limit n tends to infinity, absolute value of 2 divided by n plus 1. So limit n tends to infinity, absolute value of 2 divided by n plus 1. If you plug in n as infinity, you get 2 over infinity, which is equal to 0. So the value is equal to 0. 0 is less than 1, so it converges. So our limit n tends to infinity, an plus 1 divided by an is 0. 0 is less than 1. Therefore, n equals 1 infinity 2 to the power of n or n factorial converges. So that's how easy it is. Okay, that's it for today's video, guys. In today's video, I gave you guys an introduction of the ratio test. Hope you all have a great day, and please like and subscribe. Thank you.